Have you ever wondered how airplanes fly in the sky? They are truly engineering marvels. In this video, we will explore the principles that enable these marvelous machines to take flight. By understanding the fundamental physics at play, we can demystify the wonders of aviation. So let's dive into the world of aerodynamics and explore the force that make this airplane soar through the sky. Now, let's talk about all the forces acting on the airplane. First, we have the thrust, which is the force that pushes the airplane forward and is generated by the jet engine. Let's have a look inside of it. The fan of the engine sucks in the air and compresses it using the compressor behind the fan, which can allow it to mix with fuel for combustion in the combustor, which drives the turbine to provide electricity for the plane. The nozzle at the end of the engine can increase the flow rate of the air, increasing the thrust. This increases the speed of the airplane. Beside the thrust, there's also lift, which is generated by the airplane's wings. Now, let's have a look at an airplane's wings. The most fascinating thing on the airplane's wings is the shape. It forms a unique shape called the airfoil shape and can produce lift force for the airplane in an ingenious way. The airfoil shape is basically a curved shape as shown in this wind tunnel.
Observe how the traveling wind will be affected by this shape. It pushes the gushing wing downwards, and this can be explained by the Bernoulli's principle. So, what is it? The principle states that an increase in speed of fluid occurs simultaneously in a decrease in pressure. The air traveling above the airfoil travels faster than the air traveling below it. This causes a lower pressure on top of the wing, which pushes the air downwards. And now, Newton's third law of motion comes into the picture. If the wing pushes the wing downwards, the wind also pushes the wing in an opposite direction with an equal magnitude of force. This will eventually result in a lift force, and the aircraft will be lifted up from the ground. And it is shown by this experiment when I tie an airfoil-shaped wing on a wire and blow it with this electric fan. You can see that the wing is flying on its own. The ailerons on the wing, which are located at the tip, can move up or down, causing a difference in lift, with the aircraft now being lifted in the air. Let's talk about how it is stabilized when flying. Now, let's have a look at the airplane's vertical stabilizers, which includes the rudder. By adjusting it, you can control the horizontal force. It provides the airplane with vertical stability during the flight, and without it, the airplane will wobble from side to side and crash. The horizontal stabilizers, mounted on the tail, provide horizontal stability for the aircraft. It prevents the unnecessary up and down or pitch motion to ensure the aircraft is flying straight. By adjusting the elevators, it can control the vertical force on the tail. Now, the rest of the two forces are weight and drag, caused by gravity and air resistance. To fly faster, the airplane needs to reduce these forces acting on it. Therefore, the nose of the airplane is designed to be round. This way, we can reduce the drag of the air. You can see the difference between the air blowing on a round surface and a flat surface using this electric fan. The round surface allows the air to move freely, while the flat surface resists the flow of wind and will be blown away due to the increase of air resistance. Now, let's talk about how airplanes climb, descend, and turn. To get the airplane to take off, the elevator is tilted upwards, which pushes the tail downwards, allowing the airplane to pitch upwards. So, how the airplane change direction? The rudder produces horizontal force, and in this way, it can turn the airplane. But such a direct change will cause discomfort. To make a turn, pilots need a centrifugal force. Pilots can just make one aileron go up and one goes down, and creates a difference in lifts between the two wings, which will make the airplane roll, which can be shown by this paper plane. If I throw one wing up and one wing down, it will roll when I throw it.
And now the lift is not vertical because the plane is tilted, and the horizontal component of the lift can provide centripetal forces to bank the aircraft. This way, the pilot can make a turn. During the descent of an aircraft, the elevator is tilted down, which pushes the nose down as the airplane reaches the ground. It will lose speed and the lift will decrease, so the plane will descend and get ready for landing. This is the end of the video, and I hope you've learned about airplane physics and how they fly. Armed with this knowledge, you can now build your own airplane like I did and experience the beautiful and joyful moments of flight as the airplane soars through the sky.